Exercise 10.2. Question number 13. Find the direction cosines of the vector joining points A and B and directed from A to B. So here this point is A, which is 1, 2, -3. And this point is B, -1, -2, and 1. So let's find out vector AB, which will be equal to -1, -1, that is -2 I cap, then -2, -2, -4 j cap, then 1 -3, that is +4 k cap. So here the coefficients of I, j, k are direction ratios. So direction ratios, let's write them as A, B, C, will be equal to -2, -4, and 4. Now direction cosines L equal to A upon root of A square plus B square plus C square. It can be plus minus. Similarly, M will be B upon root of A square plus B square plus C square, and N equal to C upon root of A square plus B square plus C square. Now we can evaluate it. And direction cosines can be positive or negative. So both possibilities exist. Now, question number 14. Show that vector I cap plus j cap plus k cap is equally inclined to the axis Ox, Oy, and Oz. So suppose this is vector A, I cap plus j cap plus k cap. Now, here we can find direction ratios. So DRs are A, B, C, and they are 1, 1, 1. Now direction cosines. Will be 1 upon root of 1 square plus 1 square plus 1 square. The same will be next one. 1 upon root of, this will be root 3. This will, and next one will also be 1 upon root 3. So cos alpha equal to 1 upon root 3 equal to cos beta equal to cos gamma. Clearly, all three values are 1 upon root 3. So we can say that this vector is equally inclined to the 3-axis. Next question, find the position vector of point R which divides the line joining 2 point P and Q, whose position vectors are this and this. So here I plus 2j minus k, and second point is minus I plus j plus k. So suppose point lies here. So suppose this point is A. This ratio is 2 is to 1. So if we write this vector, so this will be a vector. Suppose this is vector small a. So it will be 1 multiplied by I plus 2j minus k. Then 2 multiplied by minus I plus j plus k divided by 2 plus 1, and we simplify. And for external division, we write minus sign here and here. So suppose it is vector B. So 1 times 1 plus 2j minus k minus 2 times minus I plus j plus k divided by 1 minus 2, because these ratios must be written in order. So here, not 1 minus 2, whatever ratios we are using here, like 2 is to 1, so 2 minus 1. So that is the answer. Now let's go to next question. Question 16. Find the position vector of the midpoint of the vector joining the points this and this. So P is 2, 3, 4, and Q is 4, 1, comma, -2. So suppose R is midpoint, so ratio will be 1:1. So position vector, suppose position vector is, we say it is OR. So it will be 2i plus 3j plus 4k times 1 plus 4i plus j minus 2k times 1 divided by 1 plus 1. On simplification, we will get the answer. Question 17. Show that the points ABC with the position vectors A 3i minus 4j minus 4k, B 2i minus j plus k cap, and vector C equal to I minus 3j cap minus 5k cap respectively, form the vertices of right angle triangle. So here we write, suppose this is A and this point is 3i minus 4j minus 4k, and this is B. So B is 2i minus j plus k, and this is C, I minus 3j minus 5k. Now, here we have to find out vector AB. So AB will be difference of the two. So 2i minus 3i, that is minus I, and then minus j plus 4j. So this will give 3j, and then k plus 4k will give 5k. We find modulus AB. So that will be equal to 1 plus 9 plus 25, that is root 35. Similarly, we find BC. BC vector means difference of the two. So I minus 2i is minus I, then minus 3j plus j plus 2j minus 5k minus k, that is minus 6k. If we find modulus BC, it will be equal to root of 1 plus 4 plus 36, which will be root 41. Now we find AC. So AC means C minus A. So I minus 3i, that is minus 2i, then minus 3j plus 4j will give j, and then minus 5k plus 4k will give minus k. So we find AC modulus, and that will be 4 plus 1 plus 1, that is root 6. Clearly, BC square equal to AB square plus AC square. Pythagoras theorem, because BC square will give 41 equal to AB square will give 35 and AC square will give 6. So this is condition for a right angled triangle. So BC square. So this will be hypotenuse, and so this figure can be redrawn. If BC is hypotenuse, so it will be like this. And this angle will be 90 degree. Now consider next question. In a triangle ABC, which of the following is not true? AB plus BC plus CA equal to 0. The rule says if one vector is in this direction, let's consider another triangle. So if one vector in this direction and another vector is in this direction, then resulting vector will be the closing side. So we can say vector A plus vector B must be equal to vector C, or if we write A, B, C, in that term, we also write vector AB plus vector BC plus vector CA equal to 0. Now, so here, and if we change this AC to this CA to AC, so it will become AB plus BC minus AC equal to 0. So here AB plus BC plus CA equal to 0 is correct answer. AB plus BC. Here we have got AB plus BC minus AC equal to 0. This is also correct option. And this is AB plus BC minus CA equal to 0. So this is not correct. And here AB minus CB minus CA. If we write this BC as CB, then it will give negative sign. If we write CA, so here again, if we write this one reverse, then it will become, so let's reconsider this point, this last one, AB minus CB minus CA equal to 0. So we know that A here from this AB plus BC. So if we write it in a reverse way, it will leave negative sign. So we can say AB plus BC. And this can be written as plus AC equal to 0. But here, this is again wrong case. So we have got answer C as wrong, and answer D is also wrong. Thank you for watching.